actually install some plugins. For example, if you go to the settings, from the settings, you will get some plugin thing. Later, you can search maybe sequence. If you write sequence, there is a tool, chief sequence diagram. So you can just install that. Later, if you run it, it will show a complete sequence diagram based on your project. So very interesting. I think you can explore by yourself that one. And later you can just write a short report on it.
Project because I have my background in Java.
Actually, Java is a kind of your object-oriented programming idea or concept. So if you do not know Java, maybe you have some idea, or maybe C+ or Python also. So all these are similar, almost similar, because they are using similar concept. They have class, they have objects, and they have say interface, abstraction, polymorphism. All these are same, but you just maybe a little bit more time because you do not need to implement it. So I think it's easy if you just go, you will understand. I think. If it's difficult, you can come to FF, or even I can also give it time through online. So we have there is another tool I found interesting, and its name is Visual Paradigm. So Visual Paradigm is also good for showing your class diagram. Actually, class diagram, we know that this is a abstract or high-level concept regarding a Java project. It will give you some the visualization of different classes. And in the class diagram, you will find that in the very top of any rectangular shape, the upper one is actually your name of the class. Later part, it will show your actual attributes of the class. Later, it will show that the constructor or other different methods. So basically, in the class diagram, you can explore that how one class actually interact with other class. So it is very good to understand the code base initially to get into very detail of that project. And that's why I have given you. So I have extended your deadline maybe 23rd this month. So we can submit it. So your next, actually, the submission is kind of 5th, right? What we have 5th of the next month. They have a class. Probably around that time we can share the actually schedule. So what you can do, you can just submit the technical report part. Though I have told you that you need to prepare 25-minute presentation, I think it's reluctant. You can start from maybe 15 minutes or maybe 20 minutes. I think it's enough. And you should start preparing the report. Have you ever used the LaTeX? Overleaf, have you used? There are different, actually, word processing softwares. So there is Google Doc. There are some other Microsoft Office. So another one is actually nowadays we are using Overleaf LaTeX. Have you heard the name LaTeX?
Yes, so we can write the report in
So we
LaTeX,
will
right?
share one LaTeX template. There you can start writing your technical reports. What do you think, Hatif?
It's fine. It's a bit of curve to learn, but it's not that difficult to learn.
Yeah, it's not being a master student of software engineering. I think it's not that much hard.
It's good for the
yes,
future if you
I
want
think
to
this will
pursue academic positions or something.
It's, I think, very easy. Nowadays, there are lots of tools make our life easy, and we have to learn those things actually.
we had a submission on
I can start seeing it from
16th
here.
of
Okay.
January.
Do you want
So-
to the next slide?
No, it's okay. Last day we have really, you have seen that there are some signals or there's some cue that our software is getting decay, or software is actually losing its efficiency or effectiveness. So this is actually some indication that our software is getting decayed. So there are some frequent, we have already covered this thing, but to coming into our context, so I'm just going through this slide again. So these are the main reasons. There are some other slides where the circle is already given, and this is the last slide. So I have not emphasized on the circle points. The first one is the frequent failures. If one system actually gets bogged down or is just failing every time, it's a very good idea that we will find some other angles. So overlay complex structure. So it is very important indication that our system is getting decayed. I think you understand the decay. You know the meaning of decay? Yeah, so degraded is getting below quality. So this is a very important reason of a complex structure. So one reason could be that if our architecture becomes so complex. So because on top of a previous architecture, we have developed so many things, and the architecture becomes actually very difficult. So over the time, there are so many programmers, and they have actually code without following standard. That could be another reason. That is for writing of coding. They do not really follow any documentation. They might have some instruction that many classes are using the same method from the same class. And I think there are lots of ratios that one structure could be overlay, and it could be used by many other classes at the same time. Even there might be some duplicate logics also. So one logic is to place one place, and for dealing with the same logic, we have implemented other places. So because many developers are actually coming into this space, and they're developing and deploying, and that's how our actually structure could be complex. So other thing is evaluation mode that we have already discussed, that if we mimic that one system is not actual, but we are trying to or pretending that this could be one actual platform to run this thing. So this is one of the reasons that our system could be decayed. So there are some other important reasons: high personal turnover. If actually of inputs of time and developer comes, they go, and this is how actually what should I say? In course of time and without proper documentation, and they do not understand the previous code, then this is how our system could be decayed. Can you go to the next slide? Okay, from this thing, from the understanding of the decay, these three important things we should be stick out to make a better quality of the software. So first issue is the technical issues. Actually, old software tends to become bloated. Bloated means actually it has so many functionalities, but it's losing its efficiency and effectiveness. This is called bloated. Bloated is sometimes called when it's something becomes inflated, but it reduces its functionality. This could be as bloated. And full of less than ideal fixes. There are lots of developers come to the environment, and if they find some error, they just fix that thing without actually analyzing the architecture of the software or the previous design. They just fix that thing without concerning the other components, how it will react with other components.
Recording in progress.
So this could be one technical issue, so we should be concerned about this thing. And management issue is a very important thing. It is told that the developer has no, we should not blame to developers. Actually, but the main problem with the management side. So in the management side, we can see that the process leaks the brain. So what is the meaning of the leak of brain? So it happens in the development organization or in the office. We find that we have poor interaction or poor communication with the customers. Then we do not understand the requirement well. So we build something, but the communication was not good. But at the 11th hour, what it happens, they give so many changes of the requirement. This is when they do not follow in the good protocol. What happens, the senior developers, they actually get so much irritated and they sometimes leave the organization. So in the middle of any large project, when a developer leaves the organization, is kind of leaks of brain actually. So when they actually leave the organization, what the poor organization does, they actually hire some developers who are not that expert. They try to implement things from that place, but without proper documentation. So this could be one, this is definitely one management issue, because the management do not follow the standard protocol practices. So last one is the quality issues. The system performance gets weaker and overall the quality declines over time. Software quality has a different perspective. It actually, the quality means is actually distinguished from one excellent product and then the poor product. So quality determines that thing. So quality could be considered or overview in different perspective. So we are coming into this. So all this need to address, but let's start with the software quality. So how can we measure actually the quality? So when we can say that something has declined too far, quality definitely one, it's a kind of, you can measure with the numbers, to the honesty. So for example, in an organization, maybe we have 2 persons, I can ask for one person for maybe one feature of a product. Then both of them might have a different perspective. So how can we measure quality and when we can say that something has declined too far? And how can we define quality and surely different processes and different types of quality? So might be we try to respond these answers. So what is actually high quality? So if you take interviews from 10 different persons, even 10 different, they might have different answers. Even people who are working in the same product, they might have different vision about the quality. So actually there is no absolute high quality. Quality has no bar actually, and it has no limit. It is limitless. Quality is always achieved, and that's why we said the limit is actually sky in terms of quality. So whatever is that, but we need to follow the standard practices to achieve the quality in the software industries. So Gravin, one scientist, he actually is a management and psychological researcher, maybe, and he defined the quality in different perspectives. One is called transcendent definition. Quality is something that is intuitively understood, but nearly impossible to communicate, such as beauty or love. So transcendent means this is actually beyond our experience, something which is not tangible, which is not cannot touch. And if we consider that one thing, this could be one quality. For example, quality is not one thing or one matter, or not even our mind. So quality, what it does, quality actually connect the human mind and the product or the thing that we actually are developing. Our quality was uncompromising in terms of standard, and quality has actually, it's a kind of Platonic terms. So in the Platonic terms, we cannot define the say love or beauty thing. So quality is kind of a type of argument. So for the quality, we should definitely should be uncompromised in terms of following the standards. And product-based definition. So product-based definition, quality, if we say quality is found in the components or attributes of product, or in the feature of a product. If you want to say in terms of what is a product-based quality, if it actually holds the significant features that one person is looking for. So this could be one product-based quality. For example, if you say, what is high quality gas? So high quality gas might have high butterfat content in certain amount of density. So, or what could you say maybe what is a good drug? So in good drug, you can say that in every inch or every centimeter, it might have good node of designs. So this could be on quality in terms of product. So in software, definitely, if we say product, say for example, on task management software. So what should it actually belong to? For example, it definitely we can assign some task. It can actually view, it can automatically integrate in the calendar. It can be any interoperable in terms of devices. So there could be many features. So if we consider what is the quality in terms of product-based definition. So when we are considering, we are judging quality in a product, whether it has sufficient or adequate features or not. So user-based definition, actually when who is holding the product, who is capturing that product, whether he is satisfied or not, then we can say that quality in terms of user perspective. So I have this software, I am the user. So if I'm happy with that product, then I should conclude that that product has a high quality, maybe because I'm the user and I'm happy. I have no complaint. So manufacturing-based definition is actually other side of the product-based quality. So manufacturer means those who are actually developing those things, whether they are following the standard practices and whether they are designing well and whether they are testing well. So this is called quality in terms of product manufacturer-based definition, whether they are following the specification, whether they are developing the right thing in right ways. So this is actually quality in terms of manufacturing definition. Other one is value-based definition. If the product is perceived as a providing good value for the price, it has good quality. So which product I'm using, whether it is compatible with the prices, then I'm satisfied that yes, with this price, what I'm using, then I can say that it's value-based definition. For example, maybe say one running shoe, it might have a cost of maybe 1,000 euro. So definitely, how it has constructed, it doesn't matter. But one running shoe is 1,000 is definitely very high. It is maybe some of the person is not affordable. So definitely for pursuing or for fulfilling my demand, it has very high price. Then we should not say that this product has high quality, because it is not complying the value. And service is really difficult thing. Whether the quality of product is actually somehow there, but when it is service, it is very difficult to measure the quality, because it has involved so many persons at the same time, and how they interact and they are doing it. For because service is kind of interminable, service is kind of it's a transcendent thing. So for example, fountain pen and food service. So fountain pen is a product. So product quality, you can make some rubrics, you can develop the rubrics, but when it is food service, so there are many things, how they are catering the things, how is that how the responsiveness, many other things could be. Yeah, so it's actually a quality and cost model. So in the x-axis, we can say that our investment level on quality, and the y-axis actually represents the total cost of maintaining and running software. One is actually quality, and other one is the total cost of the maintenance. Okay? So if you think that the blue curve, which is actually cost of quality assurance. So you can see that after a certain state, it becomes high. That means if we want to invest a lot for the quality level, sometimes it has very high cost for software maintenance, because the preventive maintenance. Do you remember the preventive maintenance? Anyone can? No, yeah. What is preventive maintenance?
The issue is still not found, but we are doing some maintenance so that in future that issue may not arise.
Right, thank you. So preventive maintenance is a kind of proactive approach. So in many software development organization, they never actually do this thing. They never actually cover this maintenance. I cannot say never, but majority of the good. So majority of the organizations, they rarely follow, or they likely overlook the preventive maintenance. So when you follow the preventive maintenance, that means we have the investment level or high investment on the quality. Actually, it has the cost of maintenance, because preventive maintenance is a part of our maintenance. So on the right hand, on the left hand side, we can see our red curve. Actually, cost of fixing the things. We have some bugs, some errors. So if we have low investment on the quality, that means we have to very high cost on the fixing the things, because we do not follow the standard practices of the quality things, and that's why it is likely we will find many errors in the maintenance level, maintenance time. So here you can see that there are two intersection points and the black curve. And the black curve actually, it's a very ideal curve. This curve actually tells you this U-shaped curve, it will tells you this is our trend should be followed so that we can make a balance between the investment level of quality and the total cost of maintenance. So though this is to finding this point is difficult, but there is some managerial way to find this point. To that, how can we find this point and how can we balance the investment level of quality and total cost of maintenance?